and welcome to this Ansys video tutorial on Totem's GDS based early analysis. In this session, we shall learn the following: how to import GDS onto Totem GUI, how to perform point-to-point resistance calculation, how to set up static IR drop analysis. This flow is usually used early on in the design cycle and can be used as long as the GDS does not have any power ground shorts. To import GDS, click on File, Import GDS. Point to the location of the GDS file here. Provide the top cell name. Provide the path of the layer map file. Hit OK. GDS has been loaded onto the Totem GUI. If you zoom in a bit, you can see all the polygon geometries within the memory array. This is the layer select window having all view, no view, all select, no select buttons. Let's move over to point-to-point resistance check. To perform point-to-point resistance check, click the middle mouse button and select GDS P2P resistance calculation. This will pull out a settings window. Make sure that you provide the correct paths for the GDS, layer map, and TeX files. Specify the net on which point-to-point resistance has to be calculated. Select the 2 points. Make sure that you have the Perform Min-Res Path option highlighted. Hit Apply. Resistance calculation is done and the Min-Res Path window is up. Along with the point-to-point resistance value, we also get the segment-by-segment distribution of the resistance along the path. The point-to-point resistance value is 1.393 ohms. The actual or effective grid resistance between them is 0.981 ohms. To set up static analysis, click the middle mouse button, then select GDS based static analysis. This will pull out a settings window. As mentioned before, make sure that you provide the correct paths for the layer map and TeX files. Also, provide the voltage values for the supply and ground nets. Then hit Apply. The block power assignment window is up. Since this is a static analysis, user has to assign the power and current consumed by the chip. Totem will then distribute this power and current to the transistors based on their sizes. To assign power or current, click New. Totem supports various styles of power assignment. Power can be assigned at a block level or on a full chip level or on a transistor level. Totem also supports region-based power assignment. Selecting MMX pin to assign power at the transistor level. Name always has to be ADSU1. Power can be assigned at any or all the layers. If VDD is selected, then power being consumed has to be assigned. If VSS, then it has to be the current assignment. The first assignment line states that all the transistor pins connected to the VDD domain will collectively dissipate a power of 10 milliwatts. The second assignment states the total current consumed by all the transistors, that is, the total current consumed by the chip, is 10 milliamps. Here we are assigning a power of 1 milliwatt to this highlighted region. After assigning the power and currents, make sure to highlight the auto analysis box. Hit Apply. Power and current assignments are done. Different maps can now be invoked to start debugging the violations. To summarize, we saw how to import GDS onto a Totem GUI, how to perform a point-to-point resistance calculation, how to set up a static IR drop analysis. Thank you for listening to this tutorial and have a nice day.